Welcome to this edition of Engineering Track. Glass is a non-crystalline amorphous solid that is often transparent or translucent. It is widely used in window panes, tableware, and electronics. On the show today, we shall bring to you process involved in the production of glass. We tracked another young innovator, Temitope Adewale, a secondary school student who has been laying his hand on engineering works. We have a lot lined up for you, but first, engineering news. This is Engineering Track, and I am Temitope Adewale.
No idea.
Iron. They use this cow bone.
Production of gas. What I think they use in the production of gas is this waste products materials like these can materials this can mods.
Glass first arrived in the time of the Egyptians 4,000 years ago. It wasn't used in construction then, but mainly to enclose small objects. By the end of the 19th century, glass was not only a luxury item, but became a construction material as common as steel and concrete. Glass is made from raw materials mixed together. These materials are sand, soda ash, and limestone. Broken glass can be added to the mixture for recycling. This mixture is melted in a furnace. The temperature inside the furnace is 1500 degrees centigrade. In this regenerating chamber, air is preheated to 1000 degrees centigrade. The materials will then begin fusing and the molten glass is stirred up. The glass is poured into a bath of liquid thin on which it floats. Coming out of the bath, the glass registered at 600 degrees centigrade. The glass must again be cooled. The sheet of glass is 3.3 meters in width. It rolls on roller gradually cooling along the way. The glass is still soft. The glass must have a uniform thickness. This laser scanner measures thickness within 100 of millimeters. The glass is now becoming hard. Next is cutting stage. This ultra-hot tungsten carbide roller makes the cuts. The glass stripes are separated and continue along the conveyor. These roller breakers cut the edges of the glass sheet. The leftover pieces fall into a container that will later be recycled. These rubber cover rollers conveys the glass sheet to inspection department. When they arrive for inspection, the glass sheets are handled with great care. The glass is inspected for faults with fluorescent light. Once inspected, the glass are handled one at a time and stored vertically. Heat fusion has transformed solid ingredients into a transparent glass and it's ready for delivery.
I use it to perform filtration method, sublimation, evaporation, separation techniques, separating two or more miscible liquid. This is my fractional distillation for separating mixture with close range of boiling point. And here is my filtration. I can use it in separating mixture that has suspended particles. There is a microscope here for viewing small and tiny things. I can use this apparatus to perform simple neutralization reaction. I can use this in performing electrolysis to verify Faraday's first law of electrolysis. Here, this apparatus is used in verifying Pascal principles, which state that the pressure exerted to an enclosed fluid is transmitted on the units to every portion of the fluid and the containing vessels as well. I have salts, acids such as potassium salt, sulfur, kerosene, water, and sodium hydroxide, which is my base. This simple machine, it also is also a separating method, but it's distillation. Here is fractional distillation. This one, I can use it to separate miscible mixtures that have a wide range of boiling point. Okay. Yes, here's my condenser, fractionating column, and there is my beaker.
Okay, this is the source of
it. Yes, sir.
Okay.
This is my meter.
Meter?
Yes.
What do you use it to measure?
I use it in testing whether a diode is working, a panel that has 14 or not, a transistor, maybe it is working or not.
This is a fault meter here.
Yes.
So you use it deflects.
Yes, just to deflect. Maybe
how about this?
This is my lens for viewing some tiny components on the cell.
Okay. How about this?
This is my lamp for working
to illuminate the surface.
Yes, sir.
Okay. How about this?
This is where my battery will stand. And these are my yes. This is my positive and this is my negative. Yes, this is my simple machine. We are taught to mention in class. So when I think of how can I apply and make something that will work exactly as our teacher told us. Okay. How mechanical energy transforms to sound energy, from sound energy to light energy, from heat energy, another source of energy. These are pulleys. Larger pulley, small pulley, how the machines work. You can test more detailed explanation on how the steel rolling at the front, steel rolling at the Osogbo, how it works. Yes, we are taught how there are some sources in which power can be generated. How electricity can be generated. Our uncle taught us tidal, a forms of wind, tidling, yes, a wind, and how an electricity is generated for a home. This is my generator, this is my transformer, and this is our house.
This is your motor.
Yes. I can
Okay,
connect
this
it
one
with a
generates
battery.
electricity.
Yes.
Okay, you convert a motor to
it. So if I found a means of power, a source of power that can tide this vein, electricity will be generated, and also through a battery supply.
Okay.
This is my wristwatch, which I mostly use in school. It works basically on photoelectric effect, as proposed by Einstein, that when the rays of light, which contain photon energy and of enough frequency, strike a metallic surface, that is possible to be an emission of electron. So with this, I'm charging my wristwatch.
Okay.
This also, I have two batteries down here, which is 33.7 volts for powering it. I can use it to make calls, listening to radios.
With
and
this?
Also, yes, and also there's a memory card in it.
Okay, does the wristwatch come with radio?
No.
Okay,
I put it
you
there.
incorporated it.
Yes, so
Can we listen to radio now?
it can remind me whenever I wanted to ring the bell in school to Temitope. Now it's 40 minutes, so it is working now manually. It can work automatically. 12:50, 40 minutes to this time, it will ring and it will vibrate, and I will know that yes, it's time for me to ring the bell. Also at night I can use it to read. Now it's charging, so this is the total amount of energy.
So you
that is present
convert
in
your
it.
wristwatch to multitasking. You are using it. What about this part?
This is my vibrator.
Okay, it vibrates.
Yes, to remind me that yes.
Okay. Okay, it's vibrating now.
Yes.
Okay, that's manual.
Yes,
but
sir.
also it works automatically. What about
Automatically.
this?
This is my laser light.
What do you use the laser for?
Sometimes I may be in the class and it will be stopping me. I can use it. I can project it on the chalkboard that Temitope Adewale is angry, and they will know. So everybody will keep on that. this watch and this food.
Okay. So this
is my speaker. This is my mouthpiece for the same course, and I can on it.
Okay, you use it to receive calls.
Yes.
Okay.
Yes, sir.
Oh, wow.
I'm separating 4 constituents: a mixture of kerosene, salt, NaCl, sand particle, and water.
Okay.
Here is my water.
That's water.
This is my beaker. This is my salt.
NaCl or salt?
NaCl.
Okay.
This is my sand particle. And here is my kerosene. Stir it. Inside this thing is contained the mixture of kerosene, salt, NaCl, sand particle, water, 4 constituents. Before this mixture can be separated, it has to undergo filtration, separation furnace, evaporation. All what remains here are 3 constituents, which are kerosene, salt, and water. I'm going for separating furnace now.
What's the next process now?
Separating furnace.
Okay.
For separating the kerosene and the water.
Kerosene and the water.
Yes.
Using
Separate. Using separating furnace.
Okay.
So this is my kerosene and this is my water. In this water, it contains salt because the salt has not been removed. But here is my kerosene. So I will go for evaporation method now so as to remove the water and the salt will be left.
What can you say motivated you into all this thing that you venture into?
The first project that I firstly do was motor. What causes motor to move? How do they move? So my mother sent me somewhere that day to buy something. So I now see the child of that person, they are playing with toys. I'm now thinking that these are motor toys. The one that I've not seen before is there. I keep going. So as I'm going, I'm thinking from Ogolua, I'm trekking to Olaya. I'm still thinking that what made the motor working? How is it working? And I can remember that the first topic we first taught in SS1 was force, motion. What causes motion? Force causes motion. Which type of force did I need? So I'm thinking like that. Till I get to stand on my table, I'm wondering, how will I do this thing, this motor? Within a short period of time, I just see that I can work one out and it's working. And I called my daddy and my mommy that, Mommy, I have made something out. My mommy was very happy, but my daddy said, Temitope, you have caused one problem. I'm now thinking that, which problem did I cause? He said, whenever you are walking on the street, you see a motor, even the one bigger than the one you did, you will still have something to be telling you that this motor, get home and do it. And this will be causing a lot of problems. So this is how this thing, all this is being bought. So I work firstly on motor.
I'm very much interested in this your wristwatch. Now, what motivated you into designing this one?
Yes, the first day I can remember, I'm very happy when they said, Temitope Adewale, you are the timekeeper of St. Charles. I'm happy. So I get home, I tell my parents that, Mommy, I've become the school timekeeper. So they're happy also. And they said, what do you need? Wristwatch. That's what I firstly tell them. And they went to the market, they buy a new wristwatch for me. And there are some certain problem that I made is that I put them into reminder. First period, second period. So it will remind me, an alarm is wasting my battery. First week, I went to the market again to buy another battery into it, 150. Another week, 150. Another week, 150. So the money is becoming too much. Okay. Now I started thinking that I too myself can do these things. Whenever I see a problem, how can I solve this problem? Through me, not through other person. How can this problem be solved? Toys.
Somebody who thinks a lot and how to solve problem that he can identify. Like the project that you have seen now, what motivated him actually is how to solve problem. Now he's now using the knowledge that he has acquired in the class to practicalize this. You can see how he made use of improvised materials, especially the one that he's doing right now, separation techniques.
Well, Temitope, I see Temitope as somebody that has a brighter future, and I see him as somebody that's so inquisitive. He wants to know. He wants to know the reason for something, even in the class. If you teach anything in the class, he wants to know. You know, some of these things that are fictions. We are talking about velocity, they are fictions. Yes. But he wants to know what is. So you have to, until you use something that he can see, or what he can lay his hand upon, that is when he will be satisfied. Okay. So sometimes encouragement, even when he does something that is wrong, you don't put him down so that you don't kill his spirit.
Temitope is a gentle boy, he's an intelligent boy, and he's also my friend. He did not like playing. He always preferred to stay in the class and read, while others are in the field. He should continue to do this and other things that he thinks he can do. he should not think about the situation around him, even when people are even thinking that all what he's doing is not good, that it is junk. He should prefer doing it, and it should not let it affect his reading, his education.
He's a serious and intelligent student, and one of the denoted students in our school. I think it's something like inspiration. He comes to him sometimes, he thinks about whether if you do any subject in the class, he'll think about something will just come into his mind for him to do something. He'll think that if I do this, can it work or not? He'll try to make something out of what he has been taught in the class. So I think it is inspiration.
I hope you enjoyed the program. Join us next time on this station. Hi, I'm Temitope Adewale.